This is the iTIG III Model B. It includes milliohm winding resistance, insulation resistance or mega measurement, DC high pot, and surge test. Optional features include capacitance, inductance, and impedance, advanced multi-coil test feature and reporting software, and partial discharge measurements. Let's get started here. Today we're testing a 460 volt, 130 horsepower assembled machine. We have our motor already entered into our database. We have our motor identification, operating voltage, and nameplate information. We're going to say test to start a new test record. We will move from left to right along the tabs in the bottom row here. We're actually on the last tab, the test summary screen. We can enter in a test description. I like to add some information about what we're testing on. In this case, it's an assembled motor. You can use the tab button here to scroll down the list. We can add a test stage if it's an incoming motor or freshly rewound outgoing motor, for example. I'll leave that blank for now. Operator information, I like to use my initials. Next step here is the setup screen. At the top we have our high pot and surge test voltage formulas. The instrument defaults to 2 times the operating voltage plus 1000. You can see here that I've already changed the recommended test voltage for the surge test to 2000. If you'd like to change it back to the recommended voltage, you can just click any of the white fields, hit enter. Now you're back to our 1920. Or enter in whatever voltage you prefer. Humidity, let's say it's a nice dry day in Colorado, 35% temperature. Maybe it's a nice hot summer day, 25 degrees. Limit setup. Default settings in this case are okay. If you would like to change any of these, click the white field and change them. After that, you can say save motor test configuration. This will then be stored for this serial number. No need to change it again. Exit setup. We're now going to start our test sets here. So first step is the winding resistance measurement. With the B model, we do the winding resistance with a separate low voltage lead set. Plugs in on the RCLC port here. Like so. 3 leads, 1, 2, 3, clearly marked and labeled. It's a Kelvin bridge style measurement. We connect to the motor over here. Lead 1 to phase 1. Lead 2 to phase 2, lead 3 to phase 3. And click the start coil symbol. The instrument will now go through and measure the winding resistance in lead 1 to 2, 2 to 3, and 3 to 1, and calculate the max delta R. If the delta R is greater than our limit, it will clearly indicate the failure. Very good. We have our resistance measurements, all nice and tight. 0% max delta R. They're 0.038 ohms. That's great. Next step is our mega measurements. Now we have to connect our high voltage lead sets. So now it's important to disconnect the low voltage lead set and reconnect our high voltage leads. So hook them onto the corresponding faces on the motor. We are good to start the mega measurement. Commonly tested on low voltage motors for the mega measurement is 500 volts. Press the red button. Use the silver dial to turn the voltage up. So you can see the applied voltage near the top center. As I'm turning the voltage higher, or increasing the voltage, you can see the inrush current. So stop turning the voltage up, it will drop off. And as we wait here, it will stabilize. We calculate the mega measurement here and correct it to 40 degrees Celsius. The chart near the center here shows the real-time leakage. You also have the option of selecting to do a stop after 1 minute, which means that the tester will automatically shut off the test set after 1 minute has passed. It will automatically calculate the DAR, the dielectric absorption ratio, after a full minute of testing. If you let it run for 10 minutes, it will automatically calculate your PI. So let's see what it looks like for the 1 minute here, and the DAR. DAR at 1.92. That's good. Red button, shut off the test, automatically discharges the windings. Next step, high pot test. High pot screen, similar to what we just did. I'm now going to select the stop after 1 minute, hit the red button. The assigned test voltage is 1920, as defined on the setup screen. Turn the silver dial up to approximately 1920. Let's see how close I can get. right about there. Now if we let it sit for a minute, the leakage current will hopefully drop off. It's at this point 0.03 microamps. That's nice and low and still falling. And we're done discharging the windings. High pot test is completed. Final step, surge test. Phase 1 is indicated. Arm the instrument, press the red button. The instrument automatically sets the time base and voltage scale. We're done with the surge test in phase 1. Select phase 2, arm the instrument, press red button. Phase 2 is done, similar to phase 3. And now we have our surge comparison. As you can see, we have a surge fail. The percentages are greater than our default pass-fail of 10%. The reason for this is that we have an assembled motor, and the orientation of the rotor is influencing our surge waveforms. So what we're going to do is we're going to redo the test starting with phase 1, but now we're going to select the pulse-to-pulse feature. Arm the instrument, press the red button. The instrument will now ask if I want to override the previous test set. I'm going to say yes. We're now going to start at a very low voltage, approximately 50 volts, and we're going to step it up at 25 volt increments all the way up to our 2000 design test voltage. We're going to do this in all 3 phases. What we're now doing is comparing each individual phase to itself throughout this voltage range. If anything happens, we will have a sudden change from one step to the next, indicating that we have a turn-to-turn, coil-to-coil, or phase-to-phase insulation issue. Okay, so we have our pulse-to-pulse measurements done. The column on the right-hand side shows the greatest percent wave difference between the voltage step in each individual phase. We also get our line-to-line comparison. We have very nice and low numbers for the pulse-to-pulse. Here, each blue bar represents the percent wave difference between the current voltage step and the previous voltage step. If we detected an arc or a failure of some sort, it would be a very tall blue bar somewhere in this bar chart. Since nothing arced here, we are all good. We have nice low percentages. We go to the last screen, test summary. We have our pass-fail recommendations. They all show pass. We are good to go. Click the folder button to exit out of the test set. You can now click View Print Pass Tests. The test we just completed is now highlighted. You can say Display Test to go back and review the results, or you can say Print Report. Let's include the pulse-to-pulse bar charts. Click Print. Formatted PDF report is now stored on the instrument. It can include your company logo. At the end of the day, you can folder all the way out to our first screen here. You can sync the files, including the printed PDF report, with the flash drive, or you have the option of transferring the same data to a PC or a server using Wi-Fi or Ethernet.